Zero-day vulnerabilities are the holy grail of discoveries for hackers, regardless of what shade their hat is. The security researchers, or white hats, that discover these vulnerabilities can oftentimes report them to the company that owns the vulnerable program or service in order to collect a cash reward called a bug bounty. And of course, the black hats, they might exploit the vulnerability for their own illegal gains, or even sell information about the vulnerability to another hacker who is more interested in pwning the vulnerable service. As the name implies, a zero-day is a previously unknown bug, and sometimes the only true way to mitigate that bug is to make changes to the source code of the problem program. Occasionally, certain configurations that are made by the end user or aspects of the system that is running the vulnerable program can provide some level of safety or make the particular bug inexploitable. But as we all know, most people just use the default settings on the most mainstream systems. And if you discover a zero-day vulnerability in one of those configurations that can allow for a full takeover of the device, then you've just stumbled upon something that could be incredibly destructive. Now, luckily, for those of us less enthralled by chaos, most zero-day vulnerabilities require a lot of knowledge about systems in order to discover and exploit them. But AI tools are starting to change that. Project Zero, the team at Google that is dedicated to studying zero-day exploits, recently used a large language model, which they call Big Sleep, in order to discover an exploitable stack buffer underflow in SQLite, which, in case you didn't know, SQLite is one of the most popular open source database applications. Not only did Google find a zero-day in a very important piece of software that a lot of people are using with their AI, but they managed to do it in a pre-release version of SQLite back in early October. And the developers were able to fix this vulnerability the same day that Google disclosed it to them. So Google and the Big Sleep agent essentially killed this bug in the cradle before it was able to affect a version of the software that anyone would actually be using in a production system. This is another huge win because a lot of people are really bad at keeping their systems up to date. So even when a zero-day bug is responsibly disclosed and the patches are rolled out, there's still a lot of systems that don't get updated and stay vulnerable to the bug for months and years. And don't even get me started on the issues with zero days in the Android ecosystem, where handsets that are made by Google might get software patches quickly and frequently, but then the ones that are made by LG or Motorola don't. AI tools like the Big Sleep agent could be a game changer for bug testing and software development. I don't think that fuzzers are going to be going away anytime soon. Those are tools that help automate the process of sending random inputs, or ideally semi-valid inputs that are valid enough to not get rejected by any input sanitization or error handling that's baked into the program, but still invalid enough to cause a crash, a memory leak, or some other kind of problem. Google even has a cloud-based fuzzing infrastructure called ClusterFuzz and OSSFuzz, which is their production variant of ClusterFuzz, and that has found over 10,000 vulnerabilities across 1,000 different projects to date. But obviously, these fuzzing tools are not silver bullets. They weren't able to find this bug in SQLite, which is actually believed to be a variant of a previously patched bug. The vulnerability that was discovered here is a very interesting one where a special sentinel value of -1 is used in an otherwise index-typed field iColumn. This pattern creates a potential edge case that needs to be handled by all of the code that uses this field because, of course, the exception would be that a valid column index is non-negative. The function series best index failed to correctly handle this edge case, resulting in a write into a stack buffer with a negative index when handling a query with a constraint on the row ID column. In the build that Google provided to their agent, debug assertions were enabled, and this condition was checked by the assertion at line 706. The bug that Google's AI tool found is loosely related to this commit that was made to the SQLite codebase, which, as you can see, this is a pretty sizable commit that was made, and I don't think it's one that a human would be able to just read through and recognize that there's a problem in here, unless perhaps they were very intimately involved with SQLite code in general, like the type of person that closes their eyes and they can basically visualize the code of SQLite. Now, the initial test case that the agent created, the AI agent created, caused runtime errors because the TCL virtual table module that they were trying to exploit was not enabled in the SQLite version that Google compiled. So the agent tried test cases that used the generate series module instead, which was enabled for this particular SQLite version. So you can see that the AI discovered that their test wasn't working, and then they adapted to testing in a different way. And using the table valued function, the agent was able to craft queries to provoke incorrect handling of constraints in where loop add virtual one. And through trial and error, it discovered that constraints on the row ID triggered an error in the series best index function within generate series. And at the end, the agent even created an accurate summary about the issues that were discovered in its research that was almost good enough as is to just copy paste into a bug report to the SQLite team. Imagine collecting a bug bounty that's worth thousands of dollars as a freelance security researcher by just submitting a bug report that was almost entirely AI generated. Now, one thing I think is worth pointing out is that this discovery is being labeled as the first AI discovered exploitable 0-day by Google and several other news outlets, but Team Atlanta probably beat Google to that earlier this year with their Atlantis cyber reasoning system that they used in the AI cyber challenge that was organized by DARPA and the White House. They uncovered and also managed to fix a vulnerability in SQLite 3 that was discovered in the FTS5 module. Now, maybe Google is just splitting hairs here by trying to claim that the vulnerability that Team Atlanta found in SQLite was not actually exploitable, but I don't think that's been completely confirmed yet. Also, Team Atlanta found the vulnerability in a production release of SQLite instead of a pre-release version like Google did. And because of that, it's very unlikely that Google's vulnerability would be exploitable too. But regardless of the biases that Google has in their accomplishment, they're still doing good work by advancing AI security tools. I hope that these tools get even better and become more available to the open source community so that free software can also become safer software. If you enjoyed this video, please like and share it to hack the algorithm.